Hi people, notes 5.6 are on verifying properties of triangles. And just a quick definition of all these different types of triangles. You have an equilateral triangle, and which you can literally like break the word up. Equi means equal, and then lateral means sides. So equilateral means all sides are equal. So what we need to show are the lengths of each side. And the way you do that is by using the distance formula. And sorry, when we say the lengths of each side, we need to show that the lengths of each side are all equal. Okay? For isosceles, isosceles means two sides are equal. So same thing, we need to find the lengths of two equal sides. So we're going to calculate their lengths, and the way we would do that is by doing the distance formula again. And then lastly are scalene triangles, which means that no sides are equal. So we have to find the lengths of all three sides and show that they are unequal. Again, the way we're going to do that is by doing the distance formula. Okay? And then lastly is a right triangle. And the way to show that something is a right triangle, there's two different ways. So one way is to show that you have two perpendicular line segments. And the way that you would do that is by using the slope formula. Or you could show that it satisfies Pythagorean theorem, which is a squared plus b squared equals c squared. And the only way we can do that is by calculating their lengths, which means that we would be using the distance formula. All right, people, let's put this in effect. Let's apply this. So the question says for number one, verify that P, Q, and R are the vertices of an isosceles triangle. So I'm going to graph out my points. So P is at 1, 1, Q is at 4, 7, and R is at 7, 4. So this is P, this is Q, this is R. So in order for me to be able to show that it is an isosceles triangle, an isosceles triangle requires two equal sides. So what we're going to do is we're going to calculate the lengths of each side. So the first side I'm going to calculate the length of is PQ. So PQ, the distance formula, just a reminder, or the length formula is x2 minus x1 squared plus y2 minus y1 squared. And it's the square root of all of that stuff. So that's what I'm going to do here. So here, this is x1, this is y1, x2, and y2. So let's go ahead and actually calculate these lengths here. So I'm going to do x2 is 4 minus x1 is 1. And then y2 is 7 minus y1 is also 1. So I end up getting the square root of 3 squared plus 6 squared, which gives me the square root of 9 plus 36, which gives me the square root of 45. So we can say here PQ is equal to the square root of 45. I'm just going to leave it as the square root right now. I'm then going to find the distance between Q and R. So I want to calculate QR. So I'm going to do the exact same thing. Now I'm going to be using these points right here. So here I can say that this is going to be 7 minus 4 squared plus 4 minus 7 squared. So that gives me the square root of 3 squared plus negative 3 squared, which gives me the square root of 9 plus 9, which gives me the square root of 18. I'm going through this pretty quickly because I'm hoping at this point in time we are comfortable with distance formula. If not, make sure you come in and get that help. Okay, all right, and then our last side that we want to show is PR or RP, whatever you prefer to call it. So PR is going to be equal to, let's say this is x1, x2, y1, y2. So this is going to be 7 minus 1 squared plus 4 minus 1 squared. So I end up getting 7 minus 1 is 6. 4 minus 1 is 3. So I end up getting the square root of 36 plus 9. So I get the square root of 45. So we can say that PR is equal to the square root of 45. And if you can see here, we notice that PQ is equal to PR. So we would just write our concluding statement right here, which would say PQ is equal to PR. Therefore, triangle PQR is an isosceles triangle. Okay, and that is our answer to this question right here. All right, our next one says to verify that P, Q, R are the vertices of a right triangle. So I'm going to graph out P, which is at negative 2, 1, Q, which is at negative 3, 4, and R, which is at 4, 3. And I want to show that this is going to be a right triangle, excuse me. So I'm going to guess that the right angle might be here, but I'm not 100% sure. So what I want to do first is to show that this has a right angle here. I have to show that QP is going to be perpendicular to PR. So I want to show that QP is perpendicular to PR. And in order for me to be able to do that, I have to use the slopes. Because once I know the slope of each, then I can show that their slopes are either going to be negative reciprocals of each other or they're not. If they are, they're perpendicular. If they're not perpendicular. So the first thing I'm going to do is find the slope of QP. So I'm going to write M of QP. So right here, I'm going to be using these 2 points right here. So I'm going to do y2, which is 4, minus y1, which is 1, over x2, which is negative 3, minus x1, which is negative 2. So I get negative 3 plus 2. So I end up getting 3 over negative 1, which is negative 3. Okay, so we know that the slope of QP is negative 3. All right, now let's go ahead and find the slope of PR. So to find the slope of PR, I would look at these 2 points right here. So I do y2 minus y1, so 3 minus 1, over x2 minus x1, which is 4 minus negative 2, which turns into 4 plus 2. So 3 minus 1 is 2, 4 plus 2 is 6, reduce that and I get 1/3. So the slope of PR is 1/3. So we know that we can say here, since the slope of QP and the slope of PR are negative reciprocals, QP is perpendicular to PR, making angle P, this one right here, a right angle. Therefore, triangle PQR is a right triangle. And that's it for this question. Okay, you also have the option to find the distance of QP, like the length of QP, the length of PR, and the length of QR, and then you can use that to find, to prove that Pythagorean theorem works. And we will talk about that in class. All right, in our last example, it says the vertices of a triangle are A, negative 3, 4, B, negative 2, negative 4, and C, 5, negative 2. So this is our triangle, so I'll connect those dots to make that triangle. And I will label the vertices of this triangle. So we've got A here, we've got B here, and we've got C right here. We're also told that D is the midpoint of AC and that E is the midpoint of AB. So we're going to actually find out all of these coordinates. So to find D, which is the midpoint of AC, by the way, you're going to have to write really small for all of these questions right here because we've got a lot of stuff going on here. So D, we want to, just a reminder that the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. And so if I want to find the midpoint of a C right here, I'm going to take A and C and find that midpoint right here. So x1 is -3, x2 is 5, y1 is 4, y2 is -2. So here I can say that D is going to be 2 over 2, and then another 2 over 2. So we know that D is going to be at 1, 1. Let's take a look at 1, 1. We can say for sure that D is going to be here. This makes sense. And then we need to do the same thing for E, where we know that E is the midpoint of AB. So this time I'm going to use these two coordinates right here. X1 and X2 are -3 and -2. So I'm going to add those together. Divide that by 2. Y2 and Y1 and Y2 are 4 and -4. I'm going to add those two together and then divide that by 2. So this turns into E becomes -5 over 2. And then 4 plus -4 is 0 over 2. So E is at -5 halves 0. Or we could say that E is at -2.50. I'm going to be using this for my calculations because it's going to be a lot easier to see and to verify what we need to verify at that point in time. But I just wrote this out as a decimal so we can see that it's going to be -2.5. So this right here is point E. All right, and we want to verify, it says here that we want to first of all verify that DE is parallel to BC. Well, to show that something is parallel to something else, we have to show that they have the same slope. So we'll start by doing this right here. So we're going to start with this right here. We want to verify DE is parallel to BC. So in order to be able to do that, we need to show that the slope of DE is equal to the slope of BC. Okay, so let's go ahead and find the slope of DE. So to find the slope of DE, I'm going to use the coordinates D and E, but I said I would use the fractions right here. So here, in order to be able to do this, I need to, just a reminder, the formula for slope is y2 minus y1 over x2 minus x1 right here. So we need to do y2 minus y1, which is 0 minus 1. So we'll do 0 minus 1 here, over x2 minus x1, which is -5 over 2, minus 1. So 0 minus 1 is easy, I get -1. Here I need to get a common denominator of 2. So this becomes -5 over 2 minus 2 over 2. So this becomes -1 over -7 over 2. Now we know that these double negatives are going to cancel each other out. So I'm just going to rewrite this right here. We also know that this means division. So we get 1 divided by 7 over 2. Don't forget that we change. So I get 2 over 7. So here we can say that the slope of DE is equal to 2 over 7. And actually I don't want to put a box around that because that's not my final answer. Okay, we also need to find the slope of BC. So let's go ahead and find the slope of BC using the points B and C. So here it's y2 minus y1, so it's -2 minus -4, which is +4, over x2 minus x1, which is 5 minus -2, or 5 plus 2. So I get 2 on top and 7 on the bottom. So here we know that the slope of BC is 2 over 7. Notice how if I was to use -5 over 2 here as -2.5, it would just be a lot harder to see that these are actually the same value. So that's why keeping it as fractions is nice and easy. Okay? All right, so we have verified that DE is parallel to BC. We'll write our concluding statement once we also verify that DE is half the length of BC. Okay, so the next thing that I want to do, so we'll call this step number 2. So here I want to show that DE, is equal to 1/2 of BC. So that means that we have to use the distance formula. So let's find DE. Okay, so to find DE, don't forget that the distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so same thing, I'm going to use D and E again, just like I did when I did my slope. So x2 is negative 5 over 2, x1 is 1. So here I'm going to do negative 5 over 2 minus 1 squared plus x1, y1 is 0, y2, sorry, is 0 minus y1 is 1. So we get 0 minus 1 squared. So here I end up getting, now I'm not going to go through and do this calculation again, because if you notice we did this calculation here and we got negative 7 over 2. So I'm not going to spend my time finding a common denominator all over again. So I get negative 7 over 2 squared plus 0 minus 1 is negative 1 squared. So this ends up becoming the square root of negative 7 over 2. When I square, it means negative 7 times negative 7 is 49. 2 times 2 is 4. And then 1 squared, negative 1 squared is 1. Okay, so this ends up becoming the square root of, I need to change this into a fraction. So 1 over 1, I'm going to get a common denominator of 4. So I get the square root of 49 over 4 plus 4 over 4, which gives me the square root of 53 over 4, which is really the square root of 53 over the square root of 4, which is the square root of 53 over 2. So here, I'm just going to squeeze this in here. I know that DE is the square root of 53 over 2. Okay, now we also need to find BC. So to find BC, I'm just going to write this out right here. It is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared, where x2 would be 5, x1 would be negative 2, y2 would be negative 2, y1 would be negative 4. So this would become 5 plus 2 squared plus negative 2 plus 4 squared. So this ends up becoming 7 squared plus 2 squared, which is the square root of 49 plus 4. Sorry, here I forgot to say square root of 7 squared plus 2 squared, which gives me the square root of 53. So we know here that BC is equal to the square root of 53, and DE is the square root of 53 over 2. So we can definitely conclude that DE is 1/2 of BC. So we can say here in our concluding statement, since the slope of DE is equal to the slope of BC, which is 2/7, DE is parallel to BC, and since DE equals the square root of 53 over 2, and BC is equal to the square root of 53, DE is 1/2 of BC. And this right here is our final solution here. We've verified these properties here. Okay, that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class.